Differentiation. In this video, let us try to understand the concept of differentiation. We know that slope between 2 points, if we take 2 points A and B, slope between any 2 points is given as slope equals to rise over run, or we can say that equals to vertical distance by horizontal distance. This is called as slope in general terms. So mathematically, when we apply this slope definition, if I take any 2 points, I can define my slope as, if I draw these projections, between these 2 points I can get a vertical distance and an horizontal distance. Let me call this vertex as C. Slope M is defined by M equals to BC upon AC. This is called as slope. Now, let us apply this concept of slope for the curves. Let us take a function f of x. This curve here indicates my function f of x. If I take 2 points, I can define the slope for these 2 points. If I take this line AB, let my A coordinate be x1 comma y1 and B will be x2 comma y2. And for this line, if I want to define the slope, they both meet at point C, and this distance is x2 here, and this distance is x1 here. Similarly, if I take the y-axis, my point A is at a distance of y1 and my point B is at a distance of y2. This is my y2. My slope M equals to distance BC upon distance AC. I can write BC equals to, this is my BC. These two lines are parallel, so this is my distance BC. I can say that BC equals to y2 minus y1 by AC equals to this part here. So this is my AC, which is x2 minus x1. So x2 minus x1. This is my slope M equals to y2 minus y1 by x2 minus x1. This is defined generally for the curves or between any 2 points. Further, if we take this concept, if I take this curve f of x, in mathematics we know that y equals to f of x. We define a function as y equals to f of x. If I take a point A, if my x coordinate is x, let's say, and the corresponding y coordinate will be f of x. Now here I am changing the terminology. For the point A, for corresponding value of x, I get the corresponding value of the y, which is f of x. When I say x, it is a distance of this point along the x-axis from the origin. This is my distance x. Along this direction, if I move a distance of h, now I am moving a distance of h, then my new x coordinate will be equals to x plus h. This is my x plus h. If I take a point B here, this B will be x plus h comma f of x plus h. So it will be f of x plus h. If x equals to x, then y equals to f of x. If my x equals to x plus h, then my y will be f of x plus h. So whatever the values of x we are having here, for those corresponding values we'll be getting the values of y here. This is how the values of the function changes. If we apply the concept of slope for this, slope m will be equals to, here this is my x1, this is my y1, this is x2 and this is y2. So it is simply y2 minus y1, that is f of x plus h minus f of x by h. So f of x plus h minus f of x by, so what I get is x plus h minus x. Nothing but I can cancel these two. What I get is f of x plus h minus f of x by h. This is the definition of slope. Now till here everything is pretty easy and we are generally talking in terms of slope. But what made the differentiation here? How the concept of this differentiation evolved from this? So Isaac Newton was working on these curves. If I think that this curve is my circle, this line is called as the secant. This line is touching the curve at 2 points A and B. I can call it as a secant. For this we define slope m equals to f of x plus h minus f of x by h. This is the slope of this curve or the line, I can say. This is called as the tangent now. This line here is called as the tangent and this curve is called as the f of x. Now this distance between 2 points A and B along the x-axis, I am calling it as h. Just try to imagine that this line AB here is moving away from this curve. So it is moving in this direction now. If it is touching the circular, if it is touching the curve, it is called as secant. If it touches the curve at 2 points, it is called as secant. If it is inside this curve, it is always called as secant. But at some particular point, let us say at this point, my line is called as the tangent to the curve. That line is called as tangent. So this line is becoming tangent at one particular point here. At this point, can we able to define the slope now? Because as we move closer and closer towards this point, C, let's say, as my line is approaching towards this point, my value of h here is tending to decrease. So if I take this line, my h value is here. This is my h value here. And if I take these 2 points, my h value is here. So like this, if I go to point C, it is decreasing and decreasing. At point C, literally the h is becoming 0. If h equals to 0, m will be undefined. But all of these lines are parallel to each other. If I am able to define the slope of this first line AB, I should be able to define the slope of these parallel lines even, because all the parallel lines have the same slope here. I can define the slope of line AB and even this line and all the lines which are secants. As soon as my secant is becoming the tangent, The moment A and B are meeting at C here, it is tending towards the 0. So Isaac Newton thought about this and he introduced a notation called as limit. He said that, fine, my slope m equals to f of x plus h minus f of x by h. The problem is that only if h equals to 0. What I do is now, I'll just think about some limit. I'll put some limit here. I'll put some limit such that my h will tend to 0. My h is tending towards the 0. For this slope f of x plus h minus f of x by h. There is a difference between h equals to 0 and h tending to 0. Now how do you understand this approaching? Imagine that you're on the terrace of a building. Now we are not allowed to stand exactly at this tip, exactly at this corner, let's say. We are not supposed to stand at this corner because we may fall down. But we can go closer and closer to this corner. It depends upon our courage and depend upon the individual. But for children, it is not allowed to go to this corner because they may fall down. Similarly here, if my value of h is exactly 0, then there is a problem. But I can go closer and closer to this 0. I can approach this 0 to the nearest value possible. Not exactly 0, but closer and closer to 0. That is the definition of h tending towards 0. So this is my value of slope for the tangent. Limit h is tending towards 0, f of x plus h minus f of x by h. But why do we call it as dy by dx? Whatever we defined here, it is the slope. We know that slope m equals to y2 minus y1 by x2 minus x1. I can write it as change in y coordinate by change in x coordinate. So change along the y-axis by change along the x-axis. This is defined for slope. I say that delta y by delta x if I have some numbers like y2 equals to some 15 and y1 equals to some 10 and x2 equals to 6 and x1 equals to 4. I can say that this is delta y. Delta y here equals to 15 minus 10, which is 5, and delta x equals to 2. I can get the value of slope here. But in coming to limits here, I'm dealing with the smaller values here. They are infinitesimally very small. I'm dealing with the infinitesimal values here. Instead of calling delta y by delta x, Newton called it as dy by dx. This dy here indicates small change along the, this is called as small change in y, and this here is called as small change in x. If it is values like 5, 2 and more than this, it's okay. But if I deal with values like 0.0001, 0.00002, let's say, whenever we are dealing with these kind of values and smaller than these values, instead of calling it as delta y, we are calling it as dy, and we use this notation of dy by dx for this limit. So dy by dx will be equals to limit my h is tending towards 0, f of x plus h minus f of x by h, and this became the fundamental theorem for the calculus or the differentiation, and this is called as the first principle, because whatever the differentiation we get, we're going to get from this principle, and this is called as the first principle. So we'll see the concepts of differentiation in the further videos. From this first principle, the concept of limits, the concept of differentiation, and also the concept of continuity came into existence. And it's a very beautiful concept. It just came from simple concept of slope. From slope, if I just apply this concept to the function f of x, and if I take a line AB, as this line approaches towards a single point, it becomes a tangent, and at this tangent my denominator value is tending towards the 0. But we should be able to define this. So instead of defining for exactly equals to 0, we can just approach the value of 0 closer and closer. And that's how this concept evolved.